some more polynomial inequalities. Now, we have an inequality that, unlike last video, is less than or equal to. So equality is part of the possible cases in the inequality. So now, all we got to do is, just like last time I told you, all you got to do is add those two terms on the right to the left and treat it like an equation. And then we'll analyze the roots on the number line like last time. So we would aspire to find the solution set. What is the solution set? We'll do so by modifying this equation by adding a 6x to both sides. And then we'll add a 1 to both sides. Notice I'm not fiddling with the orientation of the inequality because I'm not multiplying or dividing by a negative number. Notice what I've done here. I'm not multiplying or dividing by a negative number, so the inequality remains the same orientation. Okay? Now, as I told you before, this means two cases. Either this left-hand side entity is less than 0, or this left-hand side entity is equivalent to 0. Since both cases are satisfied, we will treat it like an equation, solve for the roots, then analyze the values of the numerical values of the roots. We'll analyze inputs to the left, to the middle, and to the right of those roots to figure out whether those values will either lead to a contradiction or lead to a true statement. If they lead to a contradiction, we X them out, we don't use them. If they lead to a true statement, then we'll keep them in our solution set. Okay? So now we'll treat this like an equation. 2x squared plus 6x plus 1 is equivalent to 0. Alright? Now, I want to complete the square. I don't want to factor directly. That's not something we want to do. So what I'll do is I'll divide both sides of this equation by 2. 0 divided by 2 is 0. 2 distributes to each of these terms. When it distributes to the x squared term, it becomes a 1. When it distributes to this x term, it becomes a 3. And when it distributes to the 1, it becomes a 1/2. Now, I subtract the 1/2 from both sides. So I send the constant term packing. What a minus. I left the space here because I'm going to complete the square. Alright, I get my b, which is 3. And to complete the square process, you divide b by 2 and you square the whole thing. Alright, so this ends up becoming 9/4. And I add that piece 9/4 to both sides. Okay? Now, bringing the calculation up here, this left-hand side beautifully factors to x plus b over 2, which is 3/2 quantity squared. And that is equivalent to this stuff. Negative 1/2 plus 9/4. So I'm going to multiply top and bottom here by a fancy number 1 to make them give a common denominator. So this becomes negative 2 plus 9 all over 4. This becomes 7/4. Okay? And the left-hand side is still x plus 3/2 quantity squared. Alright? So upon doing so, now we can take the square root of both sides. Alright, so I get x plus 3/2. X plus 3/2 is equivalent to plus or minus the square root of 7/4. Okay? And I get x plus 3/2 is equal to plus or minus root 7 divided by 2. Because the square root distributes to the numerator and to the denominator. When you take the square root of 7, it doesn't break down anymore. And when you take the square root of 2, you get when you take the square root of 4, you get 2. So now we have this. And when I solve for x, I get negative 3/2 plus or minus root 7 all over 2. And since they have the same denominator, we might as well let them all be expressed under the same denominator. Now I'll bring our work over here. Our positive value solution is when we elect to add here. So it's going to be negative 3 plus root 7 all over 2. And our negative solution when we elect to subtract is going to be negative 3 minus root 7 all over 2. These are our two roots. These are our two values that make this an equality. When I plug in this or that in for x here, it will equal 0. So those are points that we do want because of this piece. If this piece was not there, we wouldn't want them. But since that piece is there, we do want them. okay? But that's not the only values of x we want. We want more. So here's the real line, here's 0. Let's find where these entities lie. This entity is a negative number, so we'll put it right here, negative 3 minus root 7 all over 2. And this entity is a positive number, and it's going to land right here, negative 3 plus root 7 all over 2. Now let's think about that. Square root of 4 is 2, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9 is 3. So actually, square root of 7 is most likely a number that is less than 3, because the square root of 9 is 3. So the square root of 7 would be less than 3. So I actually rescind my statement earlier. I believe that that second value should actually be to the left of 0. It's not a big deal, but still we want to have true statements here in these videos. So we're going to shift it to the left of 0, because clearly square root of 7, since 7 is less than 9, square root of 9 is 3, so square root of 7 must be less than 3, since it's a smaller number than 9. And that's my argument for why that number is also negative. So now we have these numbers on the number line, and we want to figure out which numbers we can plug in that will work. So we want to search to the left of this, because we definitely are going to take this value we're going to take, and we want to search for the middle, and we want to search for what's to the right. Okay, let's find some value here that is on the left. Some number that's to the left of this. Clearly, negative 3 is to the left of that. So we'll use negative 3 in our calculation. Okay. So 2 times negative 3 squared plus 6 times negative 3 plus 1. Is this less than or equal to 0? Question mark. This becomes 2 times 9 minus 18 plus 1 less than or equal to 0? Question mark. Now this becomes 18 minus 18 plus 1. Is this less than or equal to question mark 0? 18's cancel, so I get 1. Is this less than or equal to 0? 1 is not less than or equal to 0, so this is a contradiction. So values to the left here, we don't want them. Big X here. Next we move on to some value that lies in between them, right here. What's the value that lies in between these two? That would require us to numerically kind of figure out what is the value that lies in between them. I will have to get a calculator out and find some value that lies in between these two. I know that maybe adding them up and dividing by 2, that would be a value that lies in between them, but that is kind of a laborious calculation. If I can numerically find what this number is, we can figure out a value that is in between there. So we just use our noggins here. We have negative 3 plus root 7 divided by 2. Well, upper estimate to the right would be, if that 7 was a 9, so it would be negative 3 plus 3, so that would be 0. So it's definitely going to be a negative number, but it's going to be slightly to the left. Is it greater than 1? Is it greater than negative 1? Well, no. Well, yes, actually, because that 2 here, this number would be greater than negative 1. And here, this number would be less than negative 1. And so negative 1 surely is a number that lies in between these two. And we can check. So let's take negative 1 right here. And so we get, plug in negative 1 for x. We got 2 times negative 1 squared plus 6 times negative 1 plus 1. Is this indeed less than or equal to 0? That's the question. This becomes 2 minus 6 plus 1. Is this less than or equal to 0? This becomes, that becomes negative 4, that becomes negative 3. Negative 3 is indeed less than 0, so these values work. Cha-chink. Now let's test a value to the right here. A value to the right, clearly 0 works, so we always want to pick 0 when that works. So let's plug in 0 for x, that's 2 times 0 squared plus 6 times 0 plus 1. Is this indeed less than or equal to 0? Question mark. That's 0, this is 0. We have 1 is less than or equal to 0. Is this true? Absolutely not. 1 is not less than or equal to 0. So these values don't work. So the only values that work are in between our two roots, are x negative and x positive. So our solution set, let's do it here. Our solution set is -3 minus root 7 all the way to -3 plus root 7 all over 2. And actually, I have put parentheses here, but we actually want to put brackets. The brackets imply that we include these values. The reason we put brackets is because our original inequality stated 2x squared plus 6x plus 1. It said, is this less than or equal to 0? And so we solve for the roots. And so this line here allows us to assert that we want to keep those brackets there because it includes those points.